All right, we're going to talk about end behavior of polynomials. And for end behavior, I know you have the table, but let's go without memorizing the table and see what we can come up with. For end behavior, the key thing that we're talking about is what happens when x gets really, really negative and when x gets really, really positive. And so I don't really care what number you think about putting in, but just imagine the sign. So let's look at this. The second thing that we care about with end behavior is the fact that the only thing that matters is the first term. So when you're looking at end behavior, only focus on the first term or the term with the highest degree, which is usually the first term when you write a polynomial. So now, let's look on the negative end. So let's look at the first term and imagine putting a negative number in here. But we're not going to worry about the negative number. Let's just assume it's a negative sign. So a negative to the 14th power. Well, every two negatives make a positive, right? Negative times negative is positive. So if I have an even power, when I take a negative to an even power, I have enough pairs of 2 that the negative will go away and become a positive. So negative to the 14th power is a positive number, but I have to multiply by -2. So I take a positive number times a negative number, I end up with negative. So as x gets more and more negative, this also becomes more and more negative. So on the left side, the function would turn down. So now let's try the right side. The right side would be positive. So I'm just going to substitute a sign. And so a positive, well, I hope this works. So a positive to the 14th power is a positive number, but when I multiply by -2, it becomes negative. So then when I get really, really positive, it goes down as well. Oops, sorry for the change in color, a technical difficulty there. So then the end behavior for this function would be down, down. All right, let's try the one on the bottom then. Add some extra color in. So for this, I only need to focus on the first term, or the term with the highest degree. So 5x to the third. And so again, let's see what happens when it's negative. So just imagine plugging in a negative sign. And so now we have a negative sign to an odd power. Well, since two negatives make a positive, any odd power will bring back an extra negative to make a negative. So negative to the third will be negative, times a positive 5 will be a negative number. So on the negative side, it's a negative number, so this function would be going down. Now let's check the positive end. And so now I've got a positive number to the third power is still positive. And then times a positive number, doesn't change anything, is still positive. So since that's positive, on that side it's going up. So therefore the end behavior of this will be down, up. And you can analyze any function in the same exact way.